All right, so section 1.5 is on solving inequalities. So when we're solving inequalities, we're going to write things in some different notations. The one that I use the most often is called interval notation. Has anybody ever done interval notation before? Yeah, okay. So the symbol is parentheses, like right parentheses, left parentheses. Are used, oh wait, I didn't read the rest of the sentence. Are used when we include an endpoint, so it should be the brackets. So if we're including an endpoint, we're going to use brackets. And then our parentheses are used when we are excluding an endpoint. So basically, if I'm including an endpoint, then maybe it looks something like this with the shading in between. See how those endpoints are filled in? That would be including the endpoints. And when I'm excluding the endpoints, maybe it says like -3 to 2, and those are open. Right? That would be not including -3 and 2. All right, so we have some examples. So we're going to do a number line for each one. We're going to talk about the inequality, and then we're going to write it in the new notation, this interval notation. So if it says we have numbers less than 4, then on a number line, I would have an open circle on 4, and then I have everything shaded on the left of it. The way you probably wrote it in Algebra 1 is you probably said all x values that are less than 4, right? So x is representing all numbers less than 4. And then the interval notation is going to be read like a book, from left to right. So when you guys read a book, you start on the left side, you go to the right, right? So the number that's way over here on the left side, we don't know. What's the biggest number you can think of? Negative infinity, right? Or well, I guess the biggest, which is really smallest, right? So we have negative infinity down here. And then we have all the way to 4. So we want to write it that way. We want to say all the numbers between negative infinity and 4. So we do negative infinity to 4. And we put a parenthesis on the 4. And then infinities will always have parentheses because you can never equal infinity. So it looks like that. So that would be interval notation. So the next one says numbers that are greater than or equal to -3. So if you are greater than or equal to -3, you're going to be everything on the right side. So the inequality would be x values that are greater than or equal to 3, like that. And our interval notation from left to right, oh, -3, darn it, Jacob got me. All right, so greater than or equal to -3. And our interval notation, if we start on the left side, the first number we hit is what number? -3, and then we go all the way to what number? Infinity, exactly. So it's going to be bracket -3 to infinity. All right, so we put a bracket on the -3 because we are including that endpoint, okay? So we include the endpoint. And then, like I said, parentheses will never have infinities because you never equal infinity. All right, so numbers between 1 and 4. So I have 1 and 4. Now, I personally think the word between is a little bit vague. All right, between actually means that you are not including the endpoints because you were between those two numbers. So we're going to do open like that. I usually am very specific if I put a question like that on the test. I would say something like numbers between 1 and 4, not including the endpoints or something, so you would know not to include the endpoints because a lot of people will fill those in. So our inequality then, these are the ones where the x is like sandwiched in the middle of the inequality. It's like 1 is less than x, which is less than 4, right? So it's really two inequalities. It's saying x is greater than 1, but x is also less than 4, right? But we write it all together. And then our interval notation, the number on the left side is 1, and the number on the right side is 4. We don't include either of them, so we write it like that. So interval notation means you include all numbers between 1 and 4 like that. And then numbers 1 through 8. If you say 1 through 8, that means you start at 1, including 1, and you go all the way through the number 8. So that does include the endpoints when you say through. And that would be 1 is less than or equal to x, which is less than or equal to 8. And in interval notation, what do you guys think it would be? Yep, bracket 1, 8, bracket. Exactly, good. So easy enough with interval notation, it's not super hard. So that's typically what you're going to use in pre-calc and AP Calc and so on. Okay, so this one says graph each set on a number line and use interval notation to represent each set of numbers. All right, so it's the same idea. So if I have 2 is less than x, which is less than 3, that means I do not include 2 and 3. because they do not have less than or equal to, right? There's no equal. So that's my number line. And then my interval notation is 2, 3, parentheses. For this next one, it says -3 to 4. -3 has a less than or equal to, and 4 is just less than. So we just have -3 with a bracket and then comma 4 parentheses. And then sometimes we're going to have ones that involve the word or. So if you have an or, what we're saying is that x is greater than or equal to 4. So it means we have all numbers that are greater than or equal to 4. Or we could have all numbers that are less than -2. So if I'm less than -2, then that's that way. So it goes off in both directions. So we're shaded on both the left and the right. Okay. And the way that we write this is we kind of just do 2 interval notations. So the first interval notation is the one that's -infinity to -2, parenthesis. And the second one is bracket 4 to infinity. But then we want to show somehow that these are included in the same answer. It's a solution to the same problem. So what we do is we put a little U between it. And this stands for union. Notice how I drew the U. I did not draw like a little stem on my U. There is no stem on the U. It's a math symbol. So it's just a U like that. And it stands for union. So it says in the above example we used the word or. You should notice that there were 2 pieces shaded on the number line. We used the symbol U called union for or statements. So that's when we have like this side or this side. Yeah.
I don't understand the difference between the parentheses and the bracket.
Okay, so one way that I always tell my students to remember is that a bracket kind of looks like a big equal sign. So remember the top and the bottom has equal. Those are the ones that are greater than or equal to. They have an equal with them. So those are the ones where you fill in the point. The point is included. Okay, but if you just have a parenthesis, then those are the open circle ones. Those are where we don't actually include the point. Okay. All right, so this next one, so use interval notation to represent the set of numbers graphed. So same idea, you just already have the number line. So this one would be -infinity to -2, parenthesis, and then union 5 to infinity, parenthesis. And the next one would be bracket -2 to 5, parenthesis. The third one would be -infinity to -2, bracket, union, parenthesis, 5 to infinity. Are you guys getting this? All right, and then what would the last one be? How about Cole? What do you think, Cole?
That would be parenthesis, -2, 5, and parenthesis.
Okay, close. Yeah, we want to put brackets. So the brackets are because it's filled in. Yep, perfect. Alrighty.
So is infinity always going to be a parenthesis?
Yeah, infinities will always have a parenthesis because you never get there. I don't know. I always tell a story about when I was little. Did you guys always get in fights with your siblings? I always got in fights with my siblings. I mean, I have a twin brother, so I don't know. We were always at each other's throats when we were kids. And so I'd be like, I hate you times infinity. And then he'd be like, I hate you times infinity plus 1. Did you guys ever have this battle with your siblings? No? Where you guys were nice to your siblings. I love you times infinity. But you never finish that argument, do you? You never end it. You never get to infinity. There's never an end to that, so there's always a parenthesis. All right, so set builder notation. This is the weird one. All right, you will see this a lot in college level math classes. It's not hard. It's actually kind of the easiest one because you can write whatever you want inside the little braces, but basically it says set builder notation is a notation for a set that uses a rule to describe the properties of the element of the set. So if you have a vertical line like that, it's read such that. So if you see this little brace thing and then x such that, it's read x such that x is greater than 4. Okay, so when we say x, it's really all numbers such that the number is greater than 4. All right, so this notation right here is called roster notation. Okay, it is just listing the elements in the set. So, you know, if you are on a basketball team and they're calling your roster, what are they doing? They're listing the members on the team, right? So it's a list of numbers. Notice how it does not have that vertical line. That's how you know it's not set builder notation. So it says write the set of numbers 0, 2, 4, 6, 8 in two different ways using set builder notation. So what are these numbers? 0, 2, 4, 6, 8. Even. Do I have negative 2, negative 4? Those are even numbers. So what should I say? Close, but we have 0 in there. Whole numbers, right? So they're whole numbers. So what I would say is you could say x such that x is an even whole number. Okay, so that's why set builder is nice, because you can literally just write it out in words on the right side, right? X such that x is an even whole number. All right, but there are other ways to write this. Now, if you were in a college course, they would write it differently, okay? And here's what they would do. So you would say something like x such that, and then you could say something like x is even, and then you might say x is an element of the whole numbers. Do you remember that notation I taught you before? So this little e that I drew is like that, element of. You do not. So with set builder, you can write it however you want, right? So another way that you could write it is you could say x is an even number starting with 0, right? Does that make sense? So you could say, or x such that x is even and x is greater than or equal to 0. That would work, right? All right, so number 2. So write the set of numbers, dot, 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 negative 3, negative 2, negative 1, 0, 1, blah, blah, blah. What numbers are those? The integers, right? So the simplest way to write it with math symbols would be x such that x is an element of the integers. You could write it like that. But if you don't want to write it that way, then you can say x such that x is an integer. That'd be fine. Do you understand the symbol? It means element of. And then this is the symbol for integers. Yeah, why is it not an I? It's weird, isn't it? They don't understand. You don't understand why it's not an I either. Didn't I tell you why it's the German word for number? I can't remember what it is. And we take German. I knew it the other day. All right. So rewrite each set in the indicated notation. All right, so this first one says, oh, you can't really see it, can you, when I'm zoomed in? All right, so we have x such that x is greater than negative 3 and x is an integer. So we're going to write this in words. So let's think about what numbers we have. If we're bigger than negative 3 and we're integers, wouldn't we have like negative 2, negative 1, 0, 1? Yeah, that would be like roster notation if I put the little braces around it. You guys hate drawing braces, don't you? Every year it's a struggle for when people draw those. Okay, so this would be in roster notation, but it wants it in words. So if we were going to write it out in words, we could say something like all numbers, or all integers, let's do it that way, all integers, you could say greater than negative 3, or you could say greater than or equal to negative 2. Or you could even say starting with negative 2, right? Does that make sense? If you start with negative 2, then you have everything after it. So I don't care how you write that out, just as long as you're describing that set. So, nope. If you write it on words, it's just like a little sentence. All right, positive multiples of 10, roster notation. Positive multiples of 10. So what would we start with? 10. What's the next one? 20. So 10, 20, 30, 40, dot, dot, dot. Goes on forever. That's roster notation. All right, all real numbers greater than 2 in set builder notation. All right, so the simplest way to write this would be x such that. We always have to do x such that when we have set builder. X is greater than 2, and that's it. So notice how I said nothing about it being a real number. if you don't write that it's a real number, we assume that it's a real number, okay? So if this had said like all integers greater than 2, we would have to say something about it being an integer. We couldn't just write it like that. All right, and then all even whole numbers, roster notation. Don't you guys like roster? Isn't roster the easiest one? It's just like list them out. All right, all even whole numbers. So what's the first even whole number?
0.
0, yep. So you have 0, 2, 4, 6, 8, ... All right, so inequalities. So we're going to talk about solving inequalities. So we've solved equations so far. Inequalities are pretty much the same. Do you guys remember the rules for inequalities, though? When do I flip the sign? Yeah, Gloria. Yeah, when you divide or multiply, right? You could multiply. So divide or multiply by a negative. All right. So let's do these ones. So it says multiplying and dividing inequalities by a positive number. So if you multiply or divide both sides of an inequality by the same positive number, the inequality sign stays the same. All right, so for example, if you have, let's do it just with regular numbers. If I have 3 is less than 5, right, that's a true statement, right? 3 is less than 5. And I decide I'm going to multiply by 2 on both sides, then my result is 6 is less than 10. Is that still true? Yeah. All right, but if I multiply or divide by a negative number, then the inequality sign changes, right? It flips. So if I had, 3 is less than 5, and I decide now that instead of multiplying by 2, I'm going to multiply by negative 2. Sorry, it looks like x minus 2. But I'm multiplying. Maybe I'll make it a fancy multiplication, an asterisk. All right, if I'm multiplying by negative 2, then what happens is I now have negative 6 and I have negative 10. And if I think about those on a number line, the negative 10 is smaller, right? So when I put my inequality, did you guys ever talk about alligators? The alligator wants to eat the bigger number. The bigger number is this one. So do you see why it has to flip? It has to flip in order to make it true. All right, so solve the following inequalities, graph the solution set on a number line, and then write your solution in interval notation. So these are the instructions that are on your homework. So it says solve it, graph it, write your final answer in interval notation. So you need all of those steps. All right, so for this first one, it doesn't matter what side you get the y on. All right, so I could subtract the 8y, subtract the 8y. And when I do that, I have 6 is less than 4y minus 18. And then I add the 18, add the 18. So I have 24 is less than 4y. So when I divide by 4, I get 6 is less than y. But I have a personal preference. You guys may not care. I like for my variables to be on the left-hand side. Okay, do you guys know why I like the variables to be on the left-hand side? Because what? Yeah, it does. Yeah, with the interval notation, kind of. Yeah, so if I have y is greater than 6 like that, see how the alligator was still eating the big side? So I kept the big side with the y. So if I'm saying 6 is smaller than the number, then the number is bigger than 6. All right, so I switched it around. Do you guys understand what I did there? And now when I put it on my number line, it points in the correct direction. So what I'm saying is this is kind of like an arrow, right? And it's now filled in the same direction as that arrow. So that's why I kind of like the variable to be on the left-hand side. It doesn't matter. So it looks like 6 to infinity in the end. All right, so I could have done that either way. So if I had instead started that problem out and I subtracted 12y on both sides, that would be okay. I have my variables on the left like I want, but at some point I would have had to divide by a negative number, right? I would have had negative 4, so I'd have to divide by that negative 4. Do you guys understand? That's when you need to flip the sign. So let's do the next one like that. So let's say I'm like, oh, I want my variables on the left-hand side. So I'm going to subtract my 4a, subtract my 4a. That gives me a negative 3a plus 9 is greater than or equal to 18. I subtract my 9. So I have negative 3a is greater than or equal to 9. And this is where I'm dividing by negative 3. I always call this the red flag rule. And I draw my little red flag. Red flag. Right, so we have to flip the sign when we do that. Okay, so this sign is now going to flip this way. So I get a is less than negative 3. Less than or equal to negative 3. Okay? Number line. Less than or equal to, so we fill in the negative 3. Our final answer is negative infinity to negative 3, bracket. So far, so good? All right, so obviously we're going to get harder. These are like Algebra 1 examples. They're going to get harder, yeah.
How do you know when to like split like a 1.6 x onto negative root on the y? How do you know like
What are you saying now?
when?
Like when they're filled in or not? Oh, are you saying like when they're on the left or the right?
Yeah.
I just was saying that in the end, like if I had that, that's fine. I just prefer it to be on the left.
No, I meant like in the interval notation.
Uh-huh.
Like 6 was on x and then negative 3 was on
Oh, like you're thinking it's like x comma y? I see what you're saying. They're not like x and y values. It's not like a point in the end. What it is it's saying like what number do you start with on the left and go to on the right. So as you fill in the interval notation, it's like I'm reading it like a book. The first thing I hit is this. So that's my first number. And I include every single number between it and positive infinity. So this interval notation says I have 6, I have 6.1, I have 6.9999, right? I have all those numbers up through infinity. So that's how we write it. So like on this other one, see how it started on the left? So we start with negative infinity and we shade everything until we get to negative 3. So just start with a number on the left and go all the way to the right. All right, so this one. Okay, so I'm going to multiply the 2 over. So I'm going to have negative 2b is greater than b minus 7. Do you see why I did not flip the sign on that? The positive number is what I was multiplying by, right? I multiplied the 2 over, so 2 is positive. All right, let's subtract the b. So we have negative 3b is greater than negative 7. Divide by negative 3. So I get b is less than positive 7/3. That was our red flag rule, right? We had to flip it. It's like drawing the red flag. Hear you saying, yes. All right, so we flip it. So I don't have you draw like super precise number lines. Like I know in like Algebra 1, you probably had to put 0 on the number line and do 1, 2, 3. I don't care. Just put 7/3 on the number line. And you want everything that is less than it, right? So we fill it in on the left. Now some people like to draw theirs above because they don't like the shading part. They can't tell where it's shaded. So if you just draw it above, that's fine as well. I don't care. All right, so our answer is negative infinity to 7/3 and then parentheses. All right, what do we think for number 4? Do we want to deal with those fractions? You like fractions? Aww. Fractions actually make your life so much easier. I mean, who likes to divide with decimals? I don't like to divide with decimals. It's much easier to like flip a fraction and multiply. Like if I do 1/2 times divided by 3/5, it's so much easier to think, okay, 1/2 times 5/3, I get 5/6, right? Who wants to do that with 1/2 divided by, what did I say, 3/5? Who wants to do it that way? That's so annoying. You just don't want any decimals or fractions ever in real life. Yeah. Mm-hmm. All right, here we go. So how are we going to get rid of the fractions? Yeah, we're going to multiply every single thing by 8, the least common denominator. So we're multiplying it in here and here and here. So you could show that step. Like some people like to write 8 times and then 3m minus 5 over 8. If you want to do that, go for it. I don't want to hold you back. You do you. So if you want to write that step where you can see 8 times, 8 times, 8 times, you can do that. The convenience in writing out that one step, which is a little bit long sometimes, is that now you can do your canceling. So you can see, okay, my 8 and my 8 cancel. And when I do that, I'm left with 3m minus 5. And then my 8 and my 4 reduce out, and I have a 2. So that's where you have to be careful because you have a minus 2 times parentheses 4 minus 5m. And then my 8 and my 4 reduce out, and I'm left with a 2. So I have greater than 2 times 3 minus 2m. All right, my sign's still the same because I was multiplying by a positive 8. So nothing changes. We're good. All right, so now we're just simplifying. So see how this is kind of a step up from what you guys did in Algebra 1. This happens a lot in Algebra 2. Like you still kind of review the concepts, but you do it a little bit more difficult equations or inequalities. All right, so I have 3m minus 5 minus 8 plus 10m is greater than 6 minus 4m. We distributed. Make sure you have plus 10m. That's the biggest mistake people will make. A couple of you guys made that mistake on your quiz too with forgetting to distribute a negative. So I have 13m minus 13 is greater than 6 minus 4m. I add my 4m over and I get 17m. I add my 13 over, I get greater than 19. And your answer is m is greater than 19 over 17. A lovely number. So we put 19 over 17 on our number line, and we want everything greater than it, so we shade on the right side. So our answer is 19 over 17, comma, infinity. That's how we write it in interval notation. All right. So Eli has at most $25.50 to spend at a gas station. He buys a candy bar and a can of soda for $1.55. It's pretty cheap. If gasoline at this store costs $2.35 per gallon, how many gallons of gasoline can Eli buy for his car to the nearest tenth of a gallon? So can we set up an inequality using x's? So we're going to let x equal the number of gallons of gas. Okay. And we're going to say he just spent $1.55 and he's going to buy a certain number of gallons of gas. If he bought 10 gallons, it'd be 10 times $2.35, right? So what we're going to do is, we don't know how many gallons, so we're going to say $2.35 times x gallons. But he has a budget. He only has $25.50, so that has to be less than or equal to that. All right, so we're going to subtract $1.55. So when we do that, it's almost $25 or $24 even, but it's a little bit less, right? 5 cents less. So $23.95. All right, who has their calculator out? Lauren, you can be my computer. So I want you to do $23.95 divided by 2.35.
14.02.
Oh, you guys are speedy. All right. So x is less than 14.02. And you can give 14.02 gallons. Like, it's never like perfectly, like when you're pumping gas, it's never like, ooh, 14 gallons exactly, right? So that's okay. So we can leave that. Oh, I guess to the nearest tenth though, doesn't it? So we'll say 14.0 gallons then. Now notice how I left that as 0.0, right? That shows that I rounded. Okay. What did I do? Oh, you got something else? Okay, so we have 10 point, oh, Becca. Okay, 10 point what? 10.19. So the answer is, ooh, do we say 10.2? I don't know. Can we say 10.2? I think you'd have to say 10.1, but that's okay. We'll do 10.2. So let's say 10.2 gallons. All right. I think that's the end, right?
Yeah.
Okay.